My name is Ludvan. I'm a software engineer at Oracle. If it involves Spatial and MySQL, I'm usually involved, unless it's actual math, because then there's someone from working on Boost Geometry. We use Boost Geometry as a library. And I do everything on, I'm involved in everything on the MySQL side. So, MySQL 8 is not out yet. We have release candidate number 2 out. Anything I say won't be used against me because it's still just a release candidate. The final release is coming in a couple of months. So I'm really excited about this. We have really achieved a lot. The main thing is geography. So I'm going to talk today about a little about coordinate reference systems, what we support there. I focus on geography, and I made it a thing to always talk about upgrade issues, because then no one can complain afterwards that, oh, but you didn't tell us this was hard when upgrading. So I'm going to tell you. I'm going to show a demo of some things and show live MySQL things, mostly. So let's get started. MySQL supports several spatial reference systems now. We didn't before. This is the first version where we actually have a table of reference systems. I can show you this in MySQL. Can you read this? So we have 5,108 reference systems in MySQL. We can look at one of them. Like this. So this is the GPS coordinate system. I'll get back to that, but just switch back to the slides for a bit. We have 5,108. 5,107 of them are from the EPSG dataset, the latest version of that. The final one is the abstract Cartesian coordinate system with no units on either axis, SRD 0, that we have supported for multiple versions. That was the only thing that MySQL 5.7 understood. That is the root of almost all of our upgrade issues, because MySQL 5.7 just ignored the SRD instead of saying, no, this is bad, only use 0. So if you did something else than 0 in MySQL 5.7, you're up for some funny upgrades. MySQL 8 will refuse to do computations unless it knows the definition. So in 5.7 it wouldn't care, but here select, let's do a no-op more or less. Text geom from text point 00. SRD 1, which is not defined. So this is a non-existing SRD. And, well, yeah, I can do that. And you see the error. There's no, put it a bit up. There's no SRS with ID 1. So MySQL won't even create that point for you. In 5.7 it would do that, and that's, as I said, the root of a lot of problems. Yeah, we have projections as well. We can show you that. SRE 3857, the Web Mercator projections. So this is Google Maps and Bing Maps and OpenStreetMap in a lot of cases. This is, well, standard compliant definition. The thing to note is, if you want to create your own, is that we don't care about these text strings or anything. We only care about these authority codes saying, yeah, this is that type of parameter, this is this and that. So the numbers and the strings are just human information. Our coordinate systems are, let's look at the 4326 again. One thing to notice is that it says axis latitude, axis longitude, because this is from the EPSG. It's latitude, longitude in that order. And we are standard compliant in that we follow the axis order defined in the spatial reference system, which means MySQL will assume that when you're entering a point in this, it's latitude, longitude. You can, of course, create your own to fix that problem. So create spatial reference system. Spatial reference system. Let's just define number 1. It needs a name. Nobody cares. MySQL doesn't care, at least. And needs a definition. And we can do the same thing as this one. That. And we say longitude east and new axis, latitude north. Oh. Finish that. And we get a warning saying that this range of SRDs is reserved by the EPSG, well, by MySQL in this case, but we do it because EPSG reserves it. So please don't meddle with this, but this is demo. I can do whatever I like. So, but please don't touch these ranges that we have reserved, because MySQL upgrade might just overwrite your data or something like that. So now we have a spatial reference system that is just the same as the 4226, but the axis order is different. So I can show you for instance, the length of a string in these systems. I think that's right. Let's do this in 4226. That is latitude, longitude, so it means this is at longitude 0, so this is the Greenwich meridian, from latitude 0, equator, to 1 degree north. That's the length in meters of that line. So if you mix up the axis orders, now it's longitude, latitude, and we see that it's slightly longer. Of course, some systems do produce latitude, longitude, some produce longitude, latitude, and we know that, so we allow you to override it, set the axis order to longitude, latitude. So this is really a latitude, longitude system, but I override it and say that this is longitude, latitude input. And the formatting is really off in this small terminal, but it's the same result as we got for SRD 0, which I defined as longitude, latitude. Okay. Yeah. So as I said, projections are supported. There's nothing fun about those. It's Cartesian, so we had the math already. Nothing new. Geography is a new thing. And we were told that the Earth is not flat in 5.7. And instead of trying to prove that it is flat, we just decided that we should change our model. We haven't tried to make a rocket to prove that it's flat. Although, if you want to create a flat Earth, you can do something very similar. You can create an ellipsoid that is so flat that it has an upside and downside. Because you can create any type of ellipsoid as long as the east-west axis is longer than the north-south axis. Actually, the WKT specification for ellipsoids doesn't allow you to specify anything else. It's a limitation on the format. And not a really bad limitation because Earth is Earth. So, and we will calculate things on this. I can create a Earth that is really small, and I will get the computations for that. Let me show you. Where was my SRE 1 there? Set at 2, but instead of, where's my spheroid? Let's make my spheroid slightly smaller. 1 digit less in the distance there. Oh, sorry, I used the same name for two spatial reference systems. That's not allowed. Too bad. The standards are strict on that. We'll do the length again. Now I can do this on SRID 2, which is much smaller Earth. And we really see that the distance now is like 11 kilometers instead of 111. So MySQL really takes into account the size of your ellipsoid. Unlike some other spatially enabled open source relational database management systems that only do 4326 SRDs. So we have the full thing. Any type of geometry, polygons, geometry collections, anything. And we index it. So we have geographic indexes in InnoDB. If you are still using MyISOM for geographic data in MySQL, then drink the Kool-Aid, get with the program, and start using InnoDB. Because we don't bother with adding stuff to MyISOM. Use InnoDB. And yeah, the SRD is what decides if it's geographic or projected. There's no geog from text. There's geom from text. As I showed you earlier, in this query, for instance, there's geom. There's no special type for geography because the SRD just decides this. As in the standard specification, it's all geometries, whether it's Cartesian or geographic. So just put a geographic SRD in here, and it's on an ellipsoid. We have a lot of functions that support geography at the moment, especially all the spatial relations like within, contains, overlaps. Anything that can make use of the R tree. We have length, but distance between points. The next talk is about distance, I think, in Boost geometry. And we are waiting for Boost to support any geometry to any geometry distance before we add it to MySQL. But it's coming. And so we add this piece by piece. So for instance, union intersection, that's missing at the moment. It will come. If you have a very strong need for a convex hull on an ellipsoid, talk to me. I haven't heard of a real use case, but if you have it, talk to me. We can try to bump it up the priority list. But we will try to go through things as we see what people need. So we're covering the basics, and then we are adding things as people the market requests. Some functions only make sense in Cartesian or geographic settings. Some functions like endpoint, start point, they don't really care. So it won't take too long before we have added this to like union intersection, I think. And then there's convex hull and that kind of thing, which is we want to see a use case as well before we spend a lot of time with it. Any questions on what we support here before I go on to the upgrade issues? Any questions on what we are able to do in MySQL? Yeah. Can you repeat that, please? DB scan? Oh yeah, clustering function. No, we don't have any clustering arguments at the moment. Sorry. Yes. Raster support. No, we don't have raster support at the moment. Only vector support. I know all these guys with satellites want to add raster support, but we don't have it yet. It's still new. We started really in 5.7 to expand this. So the big thing now is geography, and please come to us with requests for features like raster and that kind of thing. We really want to prioritize things the right way, what the community wants. We need input on that, of course. So we are really eager to listen to what people want, and we are able to shuffle our priorities a bit to match what people actually request. Let me go to upgrade issues before I can take some questions in the end as well, just to make sure that I've spoken about this and no one can complain that I didn't tell you, because we have upgrade issues. The first and simplest one is that EPSG datasets is latitude first, longitude second. We decide to follow all these standards and recommendations that says yes, you should take that into account, and so we did. But we did add the manual override because we know that people will be really angry if we didn't. We saw the MySQL, the Microsoft SQL Server thing happen, but we want to try to be standard compliant, but we see a need for the manual override. The problem is that it's only available in MySQL 8 at the moment, so you can't do it before you upgrade. But on the good side, the storage format is still longitude first, latitude second. I know people use that in MySQL 5.7. We actually had a few functions that expected that, and that storage format is exactly the same now as it used to be. SRD0 is, of course, the safe choice because that's the only thing that MySQL 5.7 actually supports. So if you say it's SRD0, then you're safe in the upgrade. And then the bad thing, you had to recreate indexes, all of them, R3 indexes. The reason is really quite simple. It's back to the same 5.7 ignores SRD thing. You could insert geometries of different SRDs into the same column and into the same index. And 5.7 just treated that as, oh yeah, it's Cartesian, it's fine, I can just do math on that. But in MySQL 8, we actually care about the SRD. So suddenly you have geographic and Cartesian data in the same index, and it doesn't make sense. So you actually have to enforce something there. I can show you the way we do that. You can create a table with a very inventive name. Geometry not null, spatial index G. Okay, so I'm creating a table with one column, geometry column. It's indexed with R3, and immediately get a warning saying that, hey, we allow you to do this because we have to support kind of dump restore upgrades. We have to be kind of SQL compatible between versions, but we won't ever use this index because you haven't locked it to one specific SRID. So if I fix this by dropping it first, and I can specify that this column is in SRD 4326, then it's fine. And now I can insert it's fine. I can try with a different SRD. Even if it's just swapped longitude, latitude, it's a different SRD, so I can't insert it. And this is the reason why we actually had to recreate all those indexes in 8.0. Luckily, we can say that the user base on GS isn't that big yet, so we can actually do this because the support for proper geometry and geography is very recent, so we can actually do this jump now and fix this really in the beginning of our work. Uh, I want to say that if you want to learn more about MySQL in general, but spatial as well, we developers do blog at mysqlserverteam.com. So I know people are nagging me to blog more there and then write about this. So yes, I will write more about the details of this. And you will find stuff about how things are done in MySQL. It's slightly different from, for instance, PostgreSQL if you come from that world, because standards have evolved since Postgres implemented these things. For instance, the name of the table, the view we had, like the name is ST spatial references, not the spatial refsys, which is in Postgres, because the standards have evolved. They have changed the names. They have modified things a bit. They even changed the column names for a few things. So we are based on a more recent standard than Postgres, and that makes for a few differences in implementation. Yeah. Are there any questions about the whole general thing? I thought there were a few more on geography before I cut it off and started on upgrades. So if there are any questions now? Yes?
In terms of precedence, what is the minimum, what is the maximum precedence?
It is a double precision floating point. So then again, it comes back to the unit you are using, which is part of this definition. So here, for instance, there's degrees and the conversion factor to radians, right? So if you have a unit that is really, really small or big, then you end up with precision issues. But I don't think you'll get a lot of precision issues if you stick to kind of normal things. But yeah, it's double precision floating points. It's typically enough for most use cases. We know that because of the math involved, it's just the nature of things that that computations are more accurate around 0, 0 than at the close to the poles and at the ends of or kind of the anti-meridian. That's just because of the math, floating points and range and that kind of thing. But I don't think you will ever get into problems with real data in this. We can certainly produce some weird results by specifically going in on the machine epsilon difference and trying to create problems for ourselves. That's certainly possible. We have several cases of that, but real data we haven't seen anything causing problems. I think we're time for one more question, please. No? Okay. Thank you for listening.